大家好，欢迎收看 CTIMES 的美国新趋势热线频道的首支单元。今天要跟大家聊聊最近的热门话题之一，也就是 Edge AI 边缘 AI。相信大家都知道，因为隐私问题、通讯安全及频宽效率等考量，因此孕育了在边缘装置上进行 AI 运算的需求。那边缘 AI 技术的开发呢，也让软硬整合的技术变得更受到重视。那选择什么样的运算晶片也就变成了一个焦点。此外，软硬整合的问题似乎也颠覆了以往的设计思维。除此之外呢，聊到 AI 这个未来化的代名词，就不免好奇究竟如何信任 AI， 什么是合理性 AI 及 AI 道德的问题呢？当然啦，聊到 AI 运算呢，我们一定得先从机器学习谈起。相信大家都知道，现在机器学习的推动模型正迅速地受到广大采用，需求面呢一直不断增加。而在边缘运算中，需要进行大量的模型训练，例如开发视觉型物件侦测时，就需要透过神经网络推断模型来处理多步骤流程。那也因为如此呢，就要因应非常大量运算的需求了。那虽然呢，在边缘执行推断模型选择是很多，但是一个实用的高速推断功能，它必须兼具灵活性、效能和节能这3个条件。那能够提供这些条件的方案呢，实在没有很多。值得一谈的呢，就是我们今天的主角 eFPGA 啦。eFPGA 跟传统 FPGA 有什么差别呢？在 eFPGA 的部分，它的 IP 核心可以内嵌在定制的 SoC 或 ASIC 上。另外，它能客制化所需的逻辑 DSP 和储存器资源的确切数量，也可以客制化调控尺寸大小及 I/O 端口数量。另外，它也能使用任意的工艺尺寸来做制造。eFPGA 目前市场上就有小编所研究，已有8家厂商在开发这项技术。其中呢 FlexLogic 公司可以说是 Edge 运算的专家，他们独特的技术让工作负载的速度提高了30到100倍呢。那我们今天呢，特别邀请到美商 FlexLogic 公司的资深产品管理总监 Sam Fuller， 还有我们的 CTIMES 社长黄俊义黄社长，一起来带大家一同探索深入了解边缘 AI 的无限可能。
Learning in general, the whole approach it's a very different approach to software development than most of us are used to, right? Writing C programs or Pascal or whatever. It is a different approach, and it's really about data and training in these kind of model frameworks. So that software has already changed to support that, and we're actually offering, yet another paradigm about separating the inference execution from the development environment. So we're essentially saying the systems that you develop these models and you train them on are not the same systems that you actually deploy on, because they're very different in terms of their optimization points. So the deployment, we can build a very efficient, very cost-effective deployment platform because we're not the same system that you need to train and develop on. It's a new concept for the industry, but I think it's absolutely important for people to understand that. When you're applying an inferencing workload, it's a very different problem. So it is very math intensive, but it's different in terms of the operations that are performed, the precision of the data itself, right? So most GPU processing is 32-bit floating point. most edge AI inferencing work is in 8-bit integer. The types of operations then are different. The data set, as I said, are different. And you're able to, when you target a device specifically for the edge AI inferencing, you can accomplish that workload with a much smaller die size and inherently less power, and a more dedicated, targeted solution. So the GPU piece of it would be, many cores that all have their own little programs that are running on the GPU side. The TPU side is typically a set of cores that are designed specifically for tensor processing. So what FlexLogix has done is really combine the TPU concept with a reconfigurable fabric concept. So we essentially have both TPUs and FPGA technology working together to create the most efficient solution for processing these edge inferencing workloads. And we do that by actually using that reconfigurability inherent in FPGA, and we actually reconfigure the processing pipeline throughout the execution of the AI workload, such that for any given stage of processing, we've configured the hardware such that it's optimally mapped to the algorithm. So that allows us to achieve the kind of leadership levels of both performance as well as efficiency, because we're in any given point, we've efficiently mapped the hardware to the problem at hand. Edge AI is obviously a very important technology. Where we see the most innovation and adoption are in industrial markets. So there's a lot of vision. So a lot of what we do is focused around solving vision problems. Vision works very well, is important at the edge because of the processing required, the bandwidth inherent in streaming video, and the latency requirements. If you're trying to, like autonomous vehicles, whether they're cars on a road or forklifts in a factory, or delivery vans or things like that, you need to have very low latency response times. So the focus is on being able to process that information locally at the edge. And then when you think about the markets, we tend to see this breakdown of industrial as the highest growth opportunity, smart cities, things like traffic intersections, safety management systems in cities, and then you'll have the manufacturing, more traditional robotics type applications. And agriculture, we're seeing a lot of uses of this in agriculture. For example, precision application of fertilizer and pesticides, where you're actually looking at the ground and seeing what you need to do, or autonomously driving the tractors in the field. Those are important applications. And then retail, I would say the last one that we see a lot of interest of and early adoption. But in the retail environment, there are both surveillance mechanisms as well as shopping mechanisms, inventory counting, checkout support systems. Lots of application areas where having computers have vision to see and understand the environment enables whole new applications and workloads. Raise concerns about bias, right? That maybe you've trained things in such a way that it'll do a better job on certain classes of people, right? Certain races and versus others. I mean, this is a personal perspective, but I think that when we move into these machine learning trained systems, as we reach higher levels of intelligence, artificial or not, in these systems, we also have to recognize that they're not 100%, right? That unlike a simple math problem, and we can do proofs on lots of things and know that we got the exact right answer. When we're working in AI systems, we're working, in these machine learning systems, everything is probabilistic, right? We talk about accuracy percentages or rates. Nothing is like I'm 100% right all the time. So we have to recognize that as we move into these environments, that we're more statistical in what we do, and then we need to make sure as we train and we set the requirements for the systems that we develop, that we're very clear on what we're trying to accomplish and what the goals are. So I think if we do those things, then we'll get what we've designed our systems to do.
瑕疵难免，那我们常讲啊，事情啊不如意事十之八九了。所以呢，既然人为的事情都已经是如此了嘛，对不对？那么你机器去做的话，要和你的意又隔了一层了。这种瑕疵你就必须去接受，然后接着再做处理这样子。后面当然一定有一定的最高指导原则，那种事情是刚刚讲的安全机制的一部分，所以在这个范围之内，就真的是不要去认为说他做对了或做错了，他就是照这个演算法去做的就是了。
We can worry that there'll be these side effects, and when they crop up and we're unhappy with the results that we've got, then we've got to go back to work and develop the system to deal with the issues that we found. But I don't think there's anything inherent in the technology that makes it any more. It's more powerful. We're obviously able to do things we haven't done before, but there's nothing inherently kind of evil or unfair about it. It's still just technology that we've developed.
AI 它们都只是一种演算法，它是一种知识的模拟。知识的模拟，它就是在它的一定的领域范围里面，在这个知识系统里面做判断、处理这样子而已。那超过它这个知识系统之外的那个，就不能再做其他的事情了，因为这件事情就牵涉到了所谓的人的意志的问题。那如果我们一直执着于这种 AI 所做的这种计算跟处理，那么它都会给人文带来冲击，变成我们人不按照自己的真正的本性来处理，而只是靠着这种AI 的判断来处理，它那是完全走样了，也不符合这个真正的本质。